It is in the best interest for Americans to have a hall of great scientists. Here is a virtual one.
It is the function of science, said Dmitri Mendeleev, to discover the existence of a general reign of order in nature and to find the causes governing this order.
Mendeleev arranged the elements in horizontal rows called periods and vertical columns called groups. This showed one set of relationships when read from side to side. The elements were arranged from left to right in ascending order of atomic weight. When grouped vertically, the columns grouped elements with similar valences and properties, such as metals or gases. Scottish physicist James Clerk Maxwell was arguably the greatest scientist of the 19th century. His work in the areas of electromagnetism, molecular behavior of gases, astrophysics, and color perception were unparalleled and have had a major impact on the world we now live in. Maxwell studied the relationship between a magnetic field and an electrical current. He developed 4 equations that were linked that he presented to the Royal Society in 1864. These equations showed that the electric and magnetic waves travel at a speed very close to that of the speed of light. This led him to a remarkable conclusion, that light itself was a form of electromagnetic wave. In 1896, French physicist Antoine-Henri Becquerel made a startling discovery. He had left a packet of uranium salts in the drawer on top of a photographic plate and later found the salts had fogged the plate. But it was Ernest Rutherford who discovered that this radioactivity was the resultant mutation of one element into another. This is actually alchemy at work, and this concept was rejected by many of his contemporary chemists. Rutherford went on to determine the nature of the nucleus of an atom by firing these alpha particles into a sheet of thin gold foil. He found, to his amazement, that in some places at more than a 90-degree angle. Rutherford described it later as quite the most incredible event that has ever happened to me in my life. It was almost as if you had fired a 15-inch shell at a piece of tissue paper and it came back and hit you. After doing some calculations, Rutherford concluded that only a powerful positive charge at the heart of the atom could have caused these positively charged particles to be deflected so dramatically. And because only about 1 in 8,000 particles bounce back, this nucleus must be approximately 8,000 times smaller than the entire atom. Max Planck was a theoretical physicist whose curiosity about the laws of nature led him to stumble upon a whole new realm of physics, quantum theory, that would transform our understanding of microphysical world of atoms and subatomic particles. The Planck constant was first described as the proportionality constant between energy E of a photon and the frequency V of its associated electromagnetic wave. The relationship between energy and frequency is called the Planck relation. This relationship seemed to imply that energy was released in tiny, indivisible chunks which Planck called quanta. This was a revolutionary notion. Until that point, it had always been assumed that energy was released in a continuous stream. Physicists suddenly had to get used to the idea of the microphysical world. The world of atoms could not be described in terms of classical physics. Albert Einstein further developed this idea to show that an electromagnetic wave, such as light, could also be described as a particle, later called a photon, with a discrete quantum energy that was dependent on its frequency. As a matter of fact, Einstein was able to use the photon theory of light to explain the photoelectric effect, for which he won the Nobel Prize in 1921. The double-slit experiment, sometimes called Young's experiment, is a demonstration that matter and energy can display characteristics of both waves and particles, and demonstrates fundamentally probabilistic nature of quantum mechanical phenomena. In the basic version of this experiment, a coherent light source such as a laser beam illuminates a plate pierced by 2 parallel slits, and the light passing through the slits is observed on a screen behind the plate. The wave nature of light caused the waves passing through the two slits to interfere, producing bright and dark bands on the screen, a result that would not be expected of light consisted strictly of particles. And while almost all of the scientists surveyed accept that human beings evolved by natural processes, and that human activity, chiefly the burning of fossil fuels, is causing global warming, the general public is far less sure. Almost a third of ordinary Americans say human beings have existed in their current form since the beginning of time, a view held by only 2% of the scientists. Thank you for visiting our museum today, where we've seen some of the research done by 4 scientists. There are many other scientists who have also contributed to the great work for society. Euclid, Archimedes, Leonardo da Vinci, Sir Robert Hooke, Sir Isaac Newton, James Hutton, John Dalton, Michael Faraday, Charles Babbage. The list can go on and on.